All right, so today we're finding zeros of polynomials. Whatever your biggest exponent is, that's how many answers you're going to have. So in this case, it's cubed, there's 3 answers. If it's to the 4th, there's 4. If it's squared, there's 2. Up until this point, it's been factored every time, so it's been really easy to see. Now it's cubed. Okay, if it's squared, we know how to solve those. We factor, we use quadratic formula. Okay, but cubed, there's not a great method. You might have learned factored by grouping before. It kind of works, but not all the time. And so it's not a great method to work through. Today, we're going to remember synthetic division. Okay, so if you remember what synthetic division looks like, we'll try to talk through that today. So based off of this polynomial, we are going to decide, is 2 a root? Is it a 0? Is it an x-intercept? Okay, a really basic way of doing that is take the number 2 and plug it into this equation. If I plugged 2 in and it was a root, what number would I get for my y value? 0. That's why it's called a 0, because your y value is a 0. Okay, you could do that, but if you just do that, you don't really get a lot of information. Okay, instead, we're going to do synthetic division because it's going to help us to find other answers as well. So remember how this works. We're going to go box and a line. Across the top here, we're going to have a list of numbers. They are going to be the leading coefficients from my polynomial. So we're going to put a 1 to represent 1x cubed, and then a -2 for the -2x squared, -9 for the x, and an 18 for that constant tagged on the end. In this box right here that I created, we are going to put whatever number we are trying to decide if it's a root or not. So since we're trying to decide, is 2 a root? I'm going to throw the number 2 in that box. And whatever number I get right here at the end will decide if it was a root or not. So here's how this works. You take whatever number is listed first and you bring it on down. So that number 1 we're going to bring on down, and I'm going to put a 1 on the bottom. Any number that's listed on bottom, you are going to multiply by whatever number's in the box. So in this case, I'm taking 2 times 1, which gets me 2, and I write it up and to the right. I stack it underneath the next number. And then it's just the same cycle until I run out of numbers. So now these two numbers right here are stacked. Anytime we stack numbers in math class, what do you think we should do with them? Add them. -2 and 2. Okay, it gets me 0. Oh, we're on bottom again. So if we're on bottom, we're going to multiply. 2 times 0 gets me 2. No, it doesn't. It gets me 0. We write it up and to the right. They're stacked, so I add. It's on bottom, so I multiply. 2 times -9 is -18. They're stacked, so I add. I get 0. Okay, 0 is going to be your best friend today. You want to get 0, because if you get 0, that tells you when you plug in 2, you would get 0. That means it's a root. It's a 0. It's an x-intercept. Not only that, but when you get 0, this is called synthetic division for a reason. It's because we're dividing out a factor. We are taking the answer of 2, specifically x minus 2, that factor, and we are dividing it out of this polynomial. And if I divide an x minus 2 out of this polynomial, I would be left with 1x squared plus 0x minus 9. It's 1 degree less than whatever we had before. We started with an x cubed, and I did synthetic division and got 0, so now that is an x squared. Okay? Or in other words, just x squared minus 9. What other answers am I going to get from x squared minus 9? 3, -3, and 2. This answer right here, and then I got 2 other answers from x squared minus 9. So what that means is, if I look at the graph of this thing, which is what's over here on your paper, you've got 3 zeros. You've got -3, you've got 2, and you've got +3. Oh yeah, just like we thought we were going to get. It just makes sure that we understand that concept. So once we do synthetic division, we are left with a quadratic, and when you're left with a quadratic, we know how to solve that. So it's just a matter of getting to that point. Questions on that first process? Let's try it again. So now we're deciding, is x plus 2 a factor? So we've got 1, -2, -9, 18. Those are my numbers. Those are my leading coefficients. If I wanted to decide if x plus 2 is a factor, what number should go in the box? -2. Because if it's x plus 2 is a factor, I'm really deciding is -2 is 0. Okay, because you got to set it equal to 0 and solve. Okay, so we're doing synthetic division. I'll remind you again, drop that 1. multiply by whatever's in the box, write it up and to the right. They're stacked, so I add. It's on bottom, so I multiply. They're stacked, so I add. It's on bottom, so I multiply. They're stacked, so I add. So my final number is 20. It is not a 0. It is not a root. It's not an x-intercept because I didn't get 0 in the end. I can't then write this as 1x squared minus 4x minus 1. That leftover stuff is garbage. It doesn't mean anything to me. But this does kind of help us a little bit because what that tells us is an ordered pair. By doing synthetic division, you still took the number -2 and you plugged it in. If you were to plug -2 into this thing, you would get 20 as your y value. That's what that tells me. So if you look at this graph over here, I know I don't have a y-axis, but yeah, -2. Oh yeah, that would make sense that that's -2, 20. At least it tells me something about my graph. I could use that to build a pretty good graph when I get done. Questions so far? All right, so the first thing we're learning, you just already learned, that is called the factor theorem. Okay, if you do synthetic division and the remainder is 0, then we know it's a factor. Okay, that's the key to what we're doing. So given this polynomial right here, we're trying to decide if x minus 4 is a factor. So we're going box and a line. 1, 1, -17, 20, and 32. If I'm trying to decide if x minus 4 is a factor, what number's going in the box? 4. A -20. I forgot the negative sign there, yes. Okay, try that one, see what you get. And try the next one. Try A and B here. Go. Here we go. We're trying the first one. When you plugged in 4, what'd you get for your answer? Show me the fingers. What'd you get when you plugged in 4? Should have gotten 0. Let's check. Drop that 1. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Oh, cool. I got 0. It was an x to the 4th polynomial. So what does this 1 right here represent? 1x to the 3rd. It's 1 less degree than what I had. So that'd be x to the 3rd plus 5x squared plus 3x minus 8. Okay. We could keep working with that problem. For right now, we're just going to be done, though. That's where it gets me, though. Okay, for the next one, for letter B, we're setting it up again. We've got 2, -1, -35, -50. Is 5 a root, so I'm throwing 5 in the box. Show me with your fingers. What'd you get? Should have gotten 0. Double check on these. If you're not getting 0, just make sure. It's way easier to get another number than it is to get 0. If you got 0, you probably got it right. If you didn't get 0, you might have made a mistake. Drop that 2. Multiply. Add. Multiply. Add. Multiply. Add. It got me 0. Yay. That is 2x squared plus 9x minus 10. Okay, again, I could solve that all the way here in a second. Here in a little bit in our notes we will. But for right now, we'll just leave it at that point. Everybody good so far on that? Letter C is a place where students make a mistake quite a bit. Given x cubed minus 1 is -1 in x-intercept. Okay, so we're going box and a line. We're trying to decide is -1 in x-intercept. So we're throwing -1 in the box. We're going to put 1 for x cubed. Then we have to put a 0 for an x squared. That's called a spacer 0. We need to include a 0 for every term. Whatever we start with, if our degree is x to the 3rd, we've got to have an x to the 3rd, an x to the 0 squared, an x, and a constant nut line. So x cubed, 0x squared, and then what would I put next? 0x, and then -1 is my constant. Okay, so be careful with that. Make sure you're including those spacer zeros. Try the next two. Go. Sure that that's true. A lot of -2s when people got this thing done. Let's see if that's true. Drop that 1. Multiply. Add. Multiply. You got to be careful here because it's really easy to switch a sign in there when you're dealing with 1s and 0s. I get -2 in the end. This doesn't mean that it didn't work. Okay, it did not work. This is not anything to us. That 1, -1, 1. If I don't get 0, then what's left over doesn't matter. But at least it does tell me an ordered pair -1, -2. Okay, once we've done that, let's try the next one. Okay, x to the 4th minus 25x squared plus 144. Box and a line. 1x to the 4th. What would come next? 0x cubed minus 25x squared. Then 0x, and then 144. Show me with your fingers. What'd you get? I should have gotten 0. Let's check. 1, multiply, add, multiply, add, multiply, add, multiply, add. I get 0. Okay, good. I wanted 0. Makes me happy inside. Make sure we're getting 0. Then once we get 0, make sure we understand what's happening after that. If this was an x to the fourth, that makes this 1x cubed plus 3x squared minus 16x minus 48. Questions with rational zero theorem? Great. Once we've done that, now we're going to move on to the next path. So far, all we've done is decided if something's a root or not. Okay. Now what we're going to do is decide what all of the answers are. Okay. So if I look at example E, it says find all of the zeros given one of them. Okay. So x minus 3 is a factor of that thing right there. I'm finding all of the zeros. Notice that this is not a question anymore. It's not saying is x minus 3 is a factor. I am telling you x minus 3 is a factor. So if I set this thing up, I've got 1, 3, negative 34, and 48. What number is going to go in the box? 3, because it's written as x minus 3. I would set that equal to 0 and solve. What am I going to get for my remainder here? 0. It is not a question. It is going to be 0 because it is a factor. And so then it's just our job not to screw it up. If you do screw it up, then go back and fix it. You know it's going to be 0. There is no option here. Okay, so you're doing your synthetic division. We do our synthetic division. We added and we multiplied. You should get 0. Make sure you do. Okay, so when I'm done with that, then I'm left with this. So Megan, what does this 1, 6, negative 16 represent here? Good. Good. And so she wrote the polynomial, x squared plus 6x minus 16. But our whole goal here is to find all of the zeros. And since it was an x cubed polynomial, I'm going to get 3 answers in the end. Okay, I'm left with this x squared. Can I solve an x squared? So let's do that. Matthew, what are we going to do? Factor it. X plus 8, x minus 2. We're going to solve that. We are finding our roots. Our roots are x is equal to 3 from that guy right there. Don't forget about that guy. 3, negative 8, and positive 2. So now we could do the same thing we did yesterday in terms of graphing it. Now we know where the 3 zeros are. All the multiplicities are 1. The degree is 3, so my ends are opposite. It's a positive, so it's going to open up. We could graph this whole thing based off of this information right here. Makes sense on E. Do F. Go. Here we go. We're doing synthetic division. We're putting 2 in the box. 3, 1, negative 10, negative 8. I know I'm getting 0 in the end. There's no question. It says it is a 0. So all we're going to do is go through and set it up. 3, 6, 7, 14, 4, 8, 0. Good. Okay, as we wanted it to be. Haley, what does this mean? Good. 3x squared plus 7x plus 4. Do your favorite method in order to solve this, but we need to solve that. It's a quadratic, so we're either factoring or quadratic formula. However makes you happy, you do that. Okay, I'm going to borrow that 3. I'm going to then factor this thing into x plus 3 and x plus 4. Don't forget to pay back. So we started off by borrowing the 3, so now I'm going to divide by 3 on both things. So my zeros, my roots are going to be x is equal to 3 divided by 3. Oh, that's 1, negative 1, negative 4/3. And what's my third answer? 2, because of this right here. We knew 2 was an answer from the start. Those are my 3 answers. Questions on F? Let's go to the back side. Okay. On the back side, this is, think about like you're in an English or a Spanish class. It's a fill in the blank worksheet. How much nicer is it when on the top you have the word box to fill in those blanks? You feel better, right? You got those words up there. Oh, okay. I'm at least knowing where I have a place to start. You still got to know some stuff, but you're a lot better off if you have a word box. That's the same thing that's happening here. Okay, now we're going to solve this problem. 2x squared minus 11x plus 12x, or 11x squared plus 12x plus 9. How many answers am I going to have? 3. And those 3 numbers right now for us could be any number in the entire world. That's a lot of numbers. That's a lot of choices. Okay. What we're going to do is be able to take that huge list and be able to pare it down to about 10 to 12 numbers. Okay. It's going to allow us to have a lot better idea of, okay, my answer lives somewhere in here. Okay. To do that, we're going to do P's and Q's. Okay. There's an example listed up there. I hate working through or looking at something that's already done. So we're just going to do one together here. So we are making a P and Q list. I do not know where the P's and Q's come from. It doesn't particularly matter. I think they just found 2 letters that they like. Okay. The P in this problem represents the constant, whatever number's at the very end. So in this case, it's the number 9. And also included in my P list are all of the factors of 9. What things multiply together to get you 9? 3 and 1. 9, 3, and 1. That is a list, an exhaustive list of all the numbers that multiply together to get you 9. My Q represents whatever is our leading coefficient. So in this case, it is the number 2. So I'm going to list the number 2 and all of the numbers that multiply together to get me 2. So 2 and 1. My list, okay, this is the list of possible rational roots. So to solve this polynomial, it could be any number in the world, but we are going to narrow it down to this small list. My list of rational zeros is going to be plus or minus always. And it's plus or minus all of my P's divided by all of my Q's. And so you just got to systematically set this thing up, though. I just throw this in parentheses. That way I know that all of them are plus or minus. But I like to just go in somewhat order. 1 divided by 1. 3 divided by 1. 9 divided by 1. That is a list of all of the numbers divided by 1. So I always even cross out that 1 because I've now used it up. Then I'm going to do the other one. 1 divided by 2. 3 divided by 2. 9 divided by 2. Boom, I'm done. I used up all my Q's. Okay, so I'm done. So out of every number in the entire world, every rational zero that could work, my list of rational zeros is now right there. It's either 1, 3, 9, 1 half, 3 halves, 9 halves, plus or minus. It's 12 numbers, but that's a whole lot less than every number in the entire world. Questions there? Try it on B. Go. So we're doing P's and Q's. Kendall, what number is my P here? 12. Whatever that last number is 12. Now I'm listing all the factors of 12. So what'd you get for that? 1, 2, 3, 4, 6. Good. Sam McCain, what's my Q going to be? 3. Whatever my leading coefficient is, it's 3. And all the numbers that multiply to get 3. 3 and 1. Okay, there's that list. Then we're doing P's over Q's. It's always plus or minus. I'm just going to list them out. Okay, so again, we're just going systematically. 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, 6 divided by 1, 12 divided by 1. Okay, all of them over 1, I used it up. Then I'm going to do them all divided by 3. So if I'm listing them all divided by 3, I'm doing 1/3, 2/3, 3/3. 3/3 is 1. I already have it listed. 4/3, 6/3. 6/3 is 2. I've already got it listed. And then 12/3. 12/3 is 4. I already got it listed. So out of every number in the world, I still got a lot of numbers, but it's a lot less than what it was before. Questions on how to find the possible rational zeros. Now we're going to use that here, and it's not a whole lot different than what we just did. Okay, find all the roots. We're going to start by finding all the possible zeros. Okay, so letter A, it says g of x is equal to that. How many solutions is this thing going to have? There are 3. So when I get done, I better have 3 answers. On the front side, it was easy because they would start you off by saying, oh, this is an answer. And then once we have that, we could factor and go on from there. Well, we don't have that here. Okay, so I'm going to do P's and Q's really quickly. My P is 8, so 8, 4, 2, and 1. My Q is 3, so 3 and 1. My P over Q list is going to be plus or minus 1, 2, 4, 8, 1/3, 2/3, 4/3, 8/3. A little bit annoying to get that started, but you got it. Okay, and it's going to help us in the end. If we get an answer in the end that's not in that list, we know we made a mistake. Okay, so it's going to help us in that way as well. All right, so we are going to do synthetic division because it's an x-cubed polynomial. I don't know how to solve an x-cubed polynomial. That's not something I have besides the idea of guess and check, okay, using synthetic division. So I'm doing my leading coefficients, 3, 1, -10, -8. What is a good number to plug in here? 1. Did anybody try 1 already? These are good problems to do with friends. Because if they tried 1 and it didn't work, then I would go on to my next one. But no one tried it, so you guys aren't very fun. We're going to do 1. Drop the 3. Multiply. Add. Multiply. Add. Multiply. Sad face. I don't really care what that number is. Okay, it tells me in ordered pair, it's 1, -14. So if I wanted to graph it and make it a little more realistic, 1, -14 is going to be on my graph. But it didn't work. Okay. And so if it didn't work, we got to do it again. So 1 didn't work. What is a number we should try next? So you can try 2. 2 is a fine number. But know that every problem that you're doing, I made it up. Okay. And I'm a nice person at heart. I'm going to not make them the hardest numbers. If 1 didn't work, then go to -1. And then go to 2. And then go -2. And then 3. And then -3. And if you get, or not, you wouldn't try 3 here. You would try 4 because 3 is not in my list. But if you get past 4 and you haven't found it yet, you made a mistake. Go back. Okay. Your number is going to be in one of those first 6 at the worst and probably earlier than that. Okay. So we're doing synthetic division again. We're going to try -1 this time. Drop that 3. Multiply. Add. Multiply. Add. Multiply. Add. I got 0. Cool. I got 0. That makes me happy. It was an x cubed problem. What is this going to be right now? This is x squared. So this is 3x squared minus 2x minus 8. Can we solve an x squared? We better be able to at this point. We just did a whole chapter on it. Okay. But we are going to solve this thing by factoring. So I'm going to do borrow and payback. I bring over that 3. So minus 24. I'm going to factor this thing into x minus 6 and x plus 4. And then I'm going to pay back that 3 that I borrowed. So my zeros, my roots, my x-intercepts are going to be x is equal to, well, this guy's going to get me a positive 2, -6 divided by 3. That's going to get me a -4/3. And what's my third answer here? -1, because we did it right there. Those are my 3 zeros to this problem. Notice that all 3 of my answers are in my list. If they weren't in my list, then I made a mistake somewhere because they have to be. That's the list of all the rational zeros. All of these are in my P's and Q's list that I had right there. Makes sense on how we solved A. Let's do it one more time with B. Okay, letter B. We're going to start off by doing a P's and Q's list. The good news is since Q is just 1, the only possible numbers are going to work here are 1, 2, 3, 6, 9, and 18. Those are the only possible numbers. It doesn't make sense to do a list of P's and Q's. Just put them together. So 1, 2, 3, 6, 9, 18. So if 3 didn't work, I would not try 4 because 4 is not going to be in there. It's just one, the plus or minus those numbers. All right. How many answers am I going to get in the end here? 4. So we're going box and a line. 1, -3, -7, 27, -18. What number should I try first? Let's try 1 because 1's easy. Okay, there's a reason we start with it. This number right here at the end would be pretty large if we're using big numbers. So like 18 is not a number we used here because that ending number is not big enough. Okay, we drop the 1, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add, yay! That makes me very happy. You want to get a 1 here because if you don't get a 1, you got to do a lot more work. So cool, we got a 1. We got a 1. What is this 1, -2, -9, 18? What does this represent right here? X to what power? Cubed. because it's 1 less than my starting degree. X cubed minus 2x squared minus 9x plus 18. Do we know how to solve a cubic function? Not with any other way than synthetic division. So it's great that we got here, but we got to keep working. Okay, I need to solve this guy right here. So I'm going to now keep doing synthetic division now with this depressed polynomial, the one that's 1 degree less. Okay, so we're going to do synthetic division again because I don't know any other way to solve it. I'm using these new leading coefficients. So 1, -2, -9, and 18. Notice that my P's and Q's are the same. They're always going to be the same. At worst, they would just be less. You don't need to list them again. We're fine. They're already in our list. Okay, 1 worked. What number do you think we should try next? -1. Any friends in the audience try -1? Yeah, should we try -1? Let's not try -1. Okay, you can if you'd like to, but I have a friend. She said don't do it. What number should I try next then? Let's try 2. Anybody try 2? All right, let's see if 2 works. You guys got to work faster. Drop that 1. It's like you're listening to me or something. Multiply by 2. Add them up. Multiply by 2. Add it up. Multiply by 2. Add it up. Yay. I got 0. That's a good thing. It was an x cubed polynomial. What does this 1, 0, -9 mean? X squared 0x minus 9. Well, that's really easy to solve. Take that, set it equal to 0 and solve it. So my roots, my zeros, my x-intercepts are going to be x is equal to. That thing right there is going to get me plus or minus 3. So 3, -3, 2, and 1. Those are the 4 zeros. Those are the 4 places I'm going to cross the x-axis. Questions on something we learned today? That's a lot of this.